In this video, I'd like to describe the electric control box that we use to power all of the components of the AC system. It's a unit that, as of now anyway, sits underneath the front right seat and again has power incoming from the inverter and power outgoing to all of the AC components. So let's get started talking about that. So here is the electrical control box for the air conditioning system. There's a circuit diagram on the top, and the supplier's name and contact information is also on the top. We've been mounting it to the floor, as I said, underneath the front right seat, simply using some Velcro. The power input side is here on this side. Also on that same side. So here's the power input. Here are the two trouble lights that will indicate, they'll light up if there is either a low or high pressure switch that's opened. And here are the thermostat connections. We're using standard thermostat wire, and we're using the red for 24 volt input. The yellow is an accessory, and the green is for the fan, the air conditioning fan. On the opposite side, we have all of the 120 volt and 24 volt output wires. There'll be a set of wires for the compressors. There'll be another set of wires for the condenser, the low and high pressure switch, and the two evaporator fans. And that's everything that gets connected to it. Now, when we get these from the supplier, Ocean Breeze, what we find is not what you're seeing here. What we find are these wires that are fed through these conduit holes. And we are ripping all of this stuff out and putting our own harnesses in, because this is just, simply put, a mess. For example, the hot wire for the right compressor is red. The hot wire for the left compressor is also red. All of these white wires, they're either neutral wires or low pressure switches. So it really makes troubleshooting, if you have a problem, very difficult. They also use these very cheap, inexpensive, quick disconnect connections. So rather than having individual connectors for individual components, as we've got here, they had individual terminals for each and every wire to each and every component, and it really created a big mess. So to make the installation easier and troubleshooting simpler, we're tearing their wiring out, putting our own in. So let's take a look at the inside of the box. There's just two Phillips head screws that come out in order to take the top off, and it just simply lifts off. It's all made of stainless steel, high quality stuff. So again, what we've got is on this side, we've got the power input from the inverter, and this is 120 volts. All of the power output is going out of the box on this side. And again, we have two compressors, we have two banks of fan, two banks of fans in our condenser, the high and low pressure switches, and the two evaporator fans. So here is the common grounding screw where everything gets, all the grounds for all the components get attached to. I believe we'll be changing this in the future to 2 screws because it's just a too crowded of a situation here with this one simple screw. Up front, you can see these 2 relays. Let me prop this up a little better so your view will be as good as mine. So these 2 relays are for the compressors. When these relays are tripped, so we have 120 volts coming in here, and we have 120 volts going out here. There's also the neutral wires in and out. And these are driven by the timers that we'll get to in a minute. So these won't trip unless the timers are allowing them to trip. But anyway, there's a left compressor relay, a right compressor relay. The fans for the evaporators also have 2 relays, and they're set up right behind the compressors. With all this wiring, I know it's a little difficult to see, but trust me, there are 2 relays, and they're exactly the same as the compressor relays. There's jumpers that go from compressor relay to evaporator fan relay to evaporator fan relay. And these evaporator fan relays are tripped whenever the fan call wire goes high. That comes from the thermostat. It's the green wire. The condenser fans also have their own relay. It's set up on the wall of the unit here. So they ran out of room when they were trying to install a relay for the condenser fans, so they mounted it high up on the wall here. And I insisted that a relay for the condenser be installed because initially there wasn't one, and we wanted individual banks of fan only coming on when the corresponding compressor got turned on. So the way it was set up originally was that both banks of condenser fans were turned on if only one side, one compressor, was turned on. And I wanted it so if a left compressor came on, then the left bank of fans on the condenser would come on. That's how it's set up now with this relay. That's what it does. A little more difficult to see are the 2 timers. There's a delay on make and a delay on break timer. The delay on break timer is simply a timer that times out after it's lost power. So it's simply not allowing a compressor to continually try to restart after it's shut down. The delay on make timer simply delays once it gains power. So it gains power, you set the timer control switch, and that's how long the timer lasts before it powers on. That's the delay on make timer. The thermostat and the pressure switches operate off of a 24-volt system. That step-down transformer is located here. So we have 120 volts coming into it, and 24 volts coming out to run the control circuit for the system. We also have two capacitors here. The compressors and the make that the evaporator fans. The compressors and the evaporator fans utilize these start-run capacitors. They won't operate without them, and so they have to be hooked up.